Hello everyone, I am Dr. Siddheshwar Chopra and today we'll learn about what are quantum mechanical operators and what is expectation value. Quantum mechanical operators. Any dynamic quantity like energy, position, linear momentum, angular momentum, etc. that can be observed or measured is known as an observable. Every observable quantity of a physical system can be represented by a suitable quantum mechanical operator. So these are the commonly known quantum mechanical operators. You see the first column is your observable, that is total energy E operator, linear momentum, that is P operator, and kinetic energy, that is P square by 2m. Position is known as X. Potential energy is V, denoted by V, capital V. Hamiltonian operator, which represents the total energy of the system, it is H. So in 1D, the operator can be written as, for total energy, it is IH cross dou by dou t. Linear momentum, it is minus IH cross dou by dou x. Kinetic energy operator minus H cross square by 2m dou square by dou x square. Position is simple x. Potential energy is V, and Hamiltonian operator, which represents the total energy, which is kinetic energy plus potential energy, is given as minus H cross square by 2m dou square by dou x square plus V. So in 3D, we can replace dou by dou x by grad, and we can replace dou square by dou x square as Laplacian operator or Laplace operator, which that makes it kinetic energy operator to be minus H cross square by 2m grad square. So these operators can be easily derived from the assumption of psi, which is equal to e to the power I kx minus omega t. All these operators can be easily derived from that. So what do we mean by expectation value? All quantum systems are described in a probabilistic manner. Different eigenvalues of a physical quantity occur with different relative probabilities. It is to be noted that the experimental value of a physical quantity may not be equal to any of the eigenvalues. In fact, the experimental value corresponds to the weighted average of the eigenvalues with their relative probabilities. The expectation value of a physical quantity is defined as the weighted average of the quantum mechanical measurements, or also called the eigenvalues, with their relative probabilities. So expectation value or average value of any function fx is given as, basically it is represented by the less than and greater than symbol. So this is the symbol for expectation value. So expectation value of fx is given as integration from minus infinity to plus infinity, or that is integrating over the entire space. Integration psi star fx psi dx by integration from minus infinity to plus infinity psi star psi dx. If you see, for a normalized wave function or the well-behaved wave function, the denominator term, this one, the denominator term becomes 1. So we can as well write the expectation value of fx to be integration from minus infinity to plus infinity psi star fx psi dx. Now this is a very important and interesting concept, and here I have listed few expectation values for few observables below here. That is your position expectation value. This is integration from minus infinity to plus infinity psi star x psi dx, or x can be taken apart, that is x mod of psi square dx, because x is a scalar, so it can be taken out here. Now the expectation value of a linear momentum is minus integration minus infinity to plus infinity psi star minus ih cross dou psi by dou x dx. Now attention has to be paid here that operator operates only on the right hand side. So the operator for the momentum, that is minus ih cross dou by dou x, has to operate on the right hand side, that is your psi here. Now v is again a scalar quantity, So here it is minus integration from minus infinity to plus infinity psi star v psi dx. The Similarly, like the linear momentum, we have another kinetic energy operator, that is p square by 2m. Expectation value for that is equal to integration minus infinity to plus infinity psi star minus h cross square by 2m dou square psi by dou x square dx. Again, the kinetic energy operator is this one. It is operating on the right hand side, that is your psi. In 3D, that can be replaced as minus h cross square by 2m grad square, or the Laplace operator. The energy expectation value is integration from minus infinity to plus infinity psi star minus is cross dou by dou t of psi dx. Again, energy operator operates on the right hand side here. That's all for the expectation value. Thank you everyone.